Hello students, welcome to the class of teacher Meenal Pereira. Today we will begin with lesson number 6, that is composition of matter. And what we are going to study in this lesson is we will be studying about physical state of matter, elements, compound, mixture and their types, and molecular formula and valency. So let's begin. First, based on our previous knowledge, can you recall? Please go to page 39. Now children, one more thing. In this lesson, there are various small questions and tables, answer of which I will be giving in the video only. So, please take a pencil or pen while seeing the video. Then and there you can write the answers. Okay, so we'll begin. What are the various states of matter? As we all know that the states of matter are solid, liquid and gaseous. What is the difference in ice, water and steam? These three substances are different in their states or different states of water. What are the smallest particle of matter called? We all know that these are known as atoms. What are the types of matter? Again, matters are of three types: solid, liquid and gaseous. Okay, so we have seen in the previous standard that all the objects that we see around us and also those which cannot be seen or made of some or other matter. So everything is made up of matter. Now, based on this, we have few more questions. Classify the following matter into three groups. So, cold drink is a liquid, air is gaseous, sharbat is a liquid, soil is solid, water is a liquid, wood is also a liquid, wood is solid and cement is liquid. What are the states of matter that you use as criteria for the above classification? So we use the solid, liquid and gaseous states. Okay, so the moral of the story is there are three states of matter: solid, liquid and gaseous, and the matter that exists around us is in all these three states. Moving further, now this is the movement or this is the experiment that tells us the movement of mustard seeds. Okay, now what is done in this experiment is, as you can see, is some mustard seeds are taken into a jar, then a diaphragm is attached to it, and then with the help of the string we are pulling the diaphragm. Now this is actually for self-study, but to study the further concepts, we need to understand the movement of the particles. Okay, so therefore I am just giving a quick view of this. Okay, so when we pull the string of the diaphragm, we see that the mustard seeds are moving. Okay, so what we are doing is, in the above experiment, we give energy less or more to the mustard seeds by pulling the diaphragm up and down, making them move differently. If we give more energy, the mustard seeds will move faster, and if we give less energy, then it will move slower. The particles in the solid, liquid and gaseous states of matter have movement somewhat similar to that. Okay, now matter or atom is a very small, very tiny particle. So we cannot see actually how it is moving. Okay, but then the collection of that makes solid, liquid and gaseous states around us. Okay, so we see some kind of movement in these three states of substance. Let's study that. Now, coming to the physical states of matter. An intermolecular force of attraction acts between the particles, that is atoms or molecules of matter. Okay, so concentrate on the word intermolecular force. Inter means inside, molecules means the small particles, and force that is the energy that binds it together. So the force of attraction, as you can see this here, we can see that these two molecules are bonded to each other by a force. The extent of the particle movement is determined by the strength of these force. That means if the force is stronger, the particles will move less. And if the force is weaker, the particles will move at a faster rate. Okay, so the particles in the solid, liquid and gaseous states of matter have movement somewhat similar to that. Okay, so remember that between the particles of solid, liquid and gaseous, the intermolecular force of attraction is there. Okay, and then depending upon the extent or how the particles are moving, depending upon how much force is there. Okay, so now we will see in case of separately solid, liquid and gaseous. Now, in case of solid state, now you can see that the particles of solid are very close to each other and vibrate at their fixed position. So very clearly you can see in the diagram that the particles are very close and they are vibrating at their fixed position. Vibration means movement. But you can see that they are not moving here and there. They are within, they have the fixed position. Due to this, solid gets properties like definite shape and volume. Okay, so we all know that the solids are having definite shape as well as volume. Volume is the space occupied by the solid, and also high density. That means weight. Density is weight, and non-compressibility. Compressibility means folding. We cannot fold the solid and fix into something. Okay, so these are the properties shown by the solids because the particles are very close to each other. Very clearly we can see in the diagram. Now moving to liquid state. Now liquid state, we know that it's an intermediate state. The particles are not very closely attracted by each other. So the strength of intermolecular force is moderate in the liquid state. Moderate means medium. It is medium. Though it is not strong enough to fix the particle in definite position, it is strong enough to hold them together. Okay, so what is the difference we can see in case of solid and liquid, children? We all know that solid has a definite shape. Liquid does not have a definite shape, but these forces can hold them together. Okay. So as a result, liquids have definite volume. Okay, so now you can see in the diagram, this is the beaker in which I have taken water. Okay, so this much is filled with water. So definite volume is there. However, they have fluidity. Fluidity means they flow from one point to another, and their shape is not definite but changes in accordance with the container. Now, if I have taken it here in a beaker, so it is having the shape of a beaker. If I am taking it in a test tube, it will have the shape of test tube. If I am taking a very big flask, it will have the shape of flask. So, depending upon the container, its shape keeps on changing. Now, coming to gaseous state, free state, freely moving here and there, as if there is no teacher in the class and you all are making mistakes. The intermolecular force is very weak in gases. As you can see here that the particles are freely moving here and there. So, the constituent particles of gas move freely and occupy all the available space. Okay, so it is everywhere. The gases occupy all the available space. Okay, consequently, gases have neither a definite shape nor definite volume. So here, because the intermolecular force of attraction is very weak, so we all know that gases do not have a definite shape nor a definite volume. Okay, so now if we compare the characteristics of the three states, that is the solid, liquid and gaseous, what we can see. Okay, so in solid state, the solid state is rigid, plastic and elastic. Rigid means strong, plastic means it could be stretched, okay, and elastic, stretched and plastic means it can be given a shape, okay. Then it has got a definite volume, definite shape, its compressibility is negligible, the intermolecular force is strong and the distance between the particle is minimum. This is the solid state where we can see all the properties. Coming to liquid, it's a fluid. Okay, fluid means flowing from one place to another. It has definite volume but indefinite shape. Its compressibility is very small. We can compress the liquid. Okay, its intermolecular force is moderate and distance between the particle is also moderate. Children, you have seen the LPG cylinders at home. Okay, now what is LPG? Is liquefied petroleum gas. So their liquid is compressed under pressure. It is compressed and filled into the container. So liquids can be compressed. Now coming to gaseous state. It's a fluid state, flows from here to there. It has got indefinite shape. Its compressibility is very high. The intermolecular forces are very weak and the distance between the particle is very large. Okay, so we can very clearly see the difference between the three states. Okay, all the three states are different. Now, the composition of some matter by means of chemical formula is given and we have to classify them accordingly. Okay, so please go to page number 40, okay, and there is a table there. So name of the material is water, its chemical formula is H2O and the type of matter is it's a liquid. Then carbon, chemical formula is C and it's a gas. Oxygen, its chemical formula is O2, again it is a gas. Air, we all know that its composition is, it's a mixture of gases. So there is no chemical formula as such. Its composition is, it is a mixture of gases. Type of matter is a gas. Aluminium, which is a metal. So its chemical formula Al, it's a solid. Then brass. Brass is an alloy. Alloy means mixture of different metals. So brass is a mixture of Cu, that is copper, Pb, that is lead, and Zn, that is zinc, and it's a solid. Then coming to carbon dioxide, its chemical formula is CO2 and it is a gas. Okay, so this is another method of classification of matter. Now what we are doing is, in this method, the criteria used for classification of matter is chemical composition of matter. We have seen in the previous standard that matter is classified into three types: element, compound and mixture, by considering whether the smallest particle of matter are similar or different and what are they made up of. Okay, so we have studied the three types, that is element. Element means single matter, single atom. Okay, compound, it is a mixture of two or more elements, okay, are combining together, and mixture means everybody gathered together. All the smallest particles, that is atoms or molecules in an element or a compound, are alike. Okay, alike means same. However, the smallest particle in a mixture are of two or more types. Okay, so based on whether the matter or whether the particles or atoms present are same or different, we have this way of classifying the matter. Okay, and when we say all the molecules are alike or same, then we called it as an element or a compound. Okay, whereas where we have different or 2-3 mixed particles together, it is called as a mixture. Okay, so you can see that water, in case of water, how many we have? 2, H2O, so hydrogen and oxygen. So it is a compound. Carbon C is an element. Okay, now let's study about this elements and molecules and compounds in the details. Okay, the smallest particle of an element contain identical atoms. Identical means same. For example, each molecule of oxygen contains 2 oxygen atoms in bounded state. You can see here, this is one oxygen molecule, this is one oxygen molecule, and what it has, it contains 2 oxygen atoms. This is the first oxygen atom, this is the second oxygen atom, and it is bonded together in a chemical state. Okay, so by intermolecular attraction it is bonded together. The smallest particles molecule of a compound are formed by joining 2 or more types of atoms to each other. Okay, and coming to compound, the smallest particles are formed by joining 2 or more types of atoms to each other. Now here we can see that oxygen is one type and H stands for hydrogen. So hydrogen is another type. So this is a compound where 2 atoms are bounded to each other. Okay. For example, each molecule of water contains 2 hydrogen atoms joined to 1 atom of oxygen. So as we can see here very clearly, children, here 1 oxygen molecule is bonded to 2 hydrogen atoms. The smallest particle of a mixture are atoms or molecules of 2 or more elements or compounds. Okay, now coming to mixture. The smallest particle of a mixture are of 2 or different more elements or compounds. For example, the main constituent molecule of mixture, namely air, are N2, that is nitrogen, O2, that is oxygen, Ar, that is argon, H2O, that is water vapor, and CO2, that is carbon dioxide. Similarly, the mixture of an alloy or mixture, that is an alloy brass, contains copper, zinc and lead, while bronze contains the atoms copper and tin. Okay, so what you have to remember here is an element means single identical atom. Molecule means 2 smallest of similar type atoms combined with each other. Whereas compound means 2 or more types of elements that are combined with each other. Okay, so element is one single. Okay, molecule means 2 identical, that means 2 same, whereas compound means 2 or more different. Okay, now coming to the tabular form. First we will see about element. Okay, element, suppose nitrogen molecule is an element. Okay, oxygen molecule is an element. Constituent substance of element is only one, and that is the element itself. Now here N2, which is the constituent element? N. Here oxygen molecule, which is the constituent element? O. Okay, so that is only one and the element itself. All the atoms or molecules of an element are alike. That means same. You can see here in the diagram also that these are looking same. All the atoms in the molecule of an element are alike and are joined to each other by chemical bonds. This also we have studied. And atoms or molecules of different elements are different. What is the meaning of this? Oxygen, the molecules are different. Nitrogen, the molecules are different. So when elements are different, atoms or molecules are also different. Now coming to compound. Now nitrogen dioxide molecule is a compound, or nitric oxide molecule is a compound. The constituent substance of a compound is only one, and it is that compound itself. all the molecules of compound are alike, that is same. The constituent atoms of a molecule of a compound are of two or more types and are joined to each other by chemical bond. Okay, now look here. This is nitrogen dioxide. Which are the two elements present here, children? The two elements is, one is nitrogen, one is oxygen. Nitric oxide. Again here two elements are there. Which are the two elements? Nitrogen and oxygen. And these two are bonded to each other by chemical. Okay. The proportion of constituent element in a compound is constant. Okay, so that means proportion, how much we are going to take is constant. Okay, so NO2, that means 1 nitrogen and 2 oxygen. Properties of a compound are different than those of the constituent element. Okay, so properties of compounds are different. And this we will study in detail. That time I will explain you how the compound form has a different properties than the constituent element. Now coming to the mixture. Mixture of nitrogen and nitrogen dioxide is shown here. Constituent substance of a mixture are two or more elements and compound. Okay, so just simple consider mixture. Bale you consider. You all eat bale, children. Okay, in that we have save, kurmura, onion, tomato, chili. All are different. Okay, all are different. It doesn't look, we don't call it as the same meat. Okay, so all are different. Atoms or molecules of a mixture are of two or more types. The constituent molecules of mixture are different from each other and are not joined by chemical bonds. In bale, the kurmura and save is not bound by chemical bond. Okay, so these are separate, different. The proportion of constituent substance in a mixture can change. Okay, I like more onion, so I will put more onion. I don't like tomatoes, I will not put tomatoes. You may like more tomatoes, so you will put more tomatoes and less onion. Okay, so the proportion is not fixed. Still, it is called as a bale. Okay, so for mixture, the constituent proportion is not same. The proportion of constituent substance are retained in the mixture. Retain means we can get it back. Okay, so for example, I don't like chili from the bale. So I will just pick up the chili and throw. Okay, so I don't have to do any chemical process or put the bale in a strainer, put water into it and then I will get chili. No, very simple, I will pick up the chili and throw. Okay, so mixture is not bonded to any of the properties as such. Okay, we can just retain the substances very easy. Okay, now coming to type of elements. Okay, now we have been, an activity is given here. Different type of objects are given: iron, nail, copper wire, aluminium wire, and piece of coal is given to us. We have to observe and find out some questions regarding it. Okay, so coming to iron, nail. Is the surface shining? Yes. For copper also it is yes. Aluminium wire shining, and coal it is not shining. Does the shape flatten or breaks into small pieces on hammering? Now suppose I am taking a hammer, okay, and beating the iron nail. It will become flat, so shape flatten. For copper wire also the shape will get flat. For aluminium wire also the shape will get flat. But the coal piece will break into small pieces. Okay, so the above activities, these are made up of element iron, copper, aluminium and carbon. Okay, so then we will fill some details. Element having a shiny surface is Fe, that is iron, Cu, copper, Al, aluminium. Elements that flatten on hammering, Fe, Cu and Al, that is iron, copper, aluminium. Element with a dull surface is coal piece, that is carbon, and elements that breaks on hammering is again carbon. Okay, so what we can conclude from this is these are the different properties that the elements are showing. Okay, and these are called physical properties because we can see. Okay, so elements has different physical properties like luster. Luster means shininess, paleness, that means it is very not at all bright. Malleability. Malleability means it could be beaten into flat shape, or we can make a flat surface from this. Or brittleness means breaks very easily. Okay, so according to the physical properties, the elements are classified. So in early times, the elements were classified into metals and non-metals. Okay, so next in few lessons, I think next lesson only, you will be studying about metals and non-metals, and there you will study the detailed property of metals and non-metals. You will also study how these two are different from each other. And after invention of new element, a new type, that is metalloid, is discovered. So what is metalloid? Metalloid means an element that shows the properties of metal as well as non-metal. Okay, so metalloid is discovered. Okay, fine. So quickly we will recap what we have studied in this video. We studied about matter, that is everything around us is made up of matter. The states of matter, there are 3 states of matter: solid, liquid and gaseous. Then we studied about the characteristics of states of matter, that is all the characteristics, that means solid, liquid and gases have different characteristics. Just to example, the intermolecular forces of attraction between them are different. And we also studied about the types of elements. I hope it is clear to everyone. Thank you very much. Take care.